Alright, welcome to part 2. Part 2, we're looking at property 2. Property 2 is division. So when we divide our exponents, when we divide anything that has the same base, we're going to subtract the exponents. So when we subtract, some people like to think of this as a tug of war. Well, who's going to win the tug of war, 13 or the 6? Well, that's easy. 13's bigger, so he wins the tug of war. And how far does he win? He wins by 7. So we always subtract our exponents. Let's look at some example problems from part 2. So part 2 on our all homework page. I notice number 1, I've got two different pieces. I've got the 8 divided by the 2, and then I have the t's over here. Well, 8 divided by 2 is easy. That's 4. So the question is, does the 4 live on the top or on the bottom? Well, of course, the 4 is going to be on the top because the big number always goes on the top. Or the big number is on the top. Now let's look at our t's. I have a t to the first power up top and a t to the second power on the bottom. Who's going to win the tug of war, the top or the bottom? Well, the bottom's going to win. Well, how much does he win by? He wins by 1, whatever 2 minus 1 is. So I have t to the first power. Now we really don't have to write that first power, but we're going to write it anyway, just to make sure that we've got it down. Now let's look at number 6. Number 6 is probably the most missed problem. The reason being is because folks come in here and they look at these big, beautiful 8s and they go, oh, that's easy. 8 divided by 8 is 1. And they completely ignore the exponents. The problem is that if you took 8 and raised it to the 7th power in the calculator, you get 2 million and a whole bunch of numbers after it, okay? It's not just 8, all right? So we're going to pretend they're x's. If I had x to the 7th over x to the 5th, I have a 7 on top, 5 on the bottom. 7 wins the tug of war. Well, how much does he win the tug of war by? 2. And the 2 goes on top because the 7 was on top. So let's apply the same principle here. I have 8 to the 7 on top, 8 to the 5th on the bottom. Tug of war between the 7 and the 5 is 2. The 8 squared, because 2 is now the exponent for the 8, goes on the top because the 8 to the 7th was on the top. Well, 8 squared is easy. That's just 64. So my answer is 64. Let's look at number 11. Number 11 is kind of a combination problem. I notice I have these big, beautiful parentheses here. So that tells me I've got to multiply in parentheses to a power. We're going to distribute that power. For division, that means both the top and the bottom get multiplied by this exponent. So I'm going to have x squared, and then I got to multiply that exponent by 2. And then the 9 is to the first power, and we're going to multiply that exponent by 2. Well, the top's really easy because 2 times 2 is 4, so that's just x to the 4th. And now let's look at the bottom. 1 times 2 is 2, so 9 squared is, you got it, 81. So my answer becomes x to the 4th divided by 81. Well, let's look at number 16. Number 16 looks like another combination problem. And the reason why it looks like a combination problem is because I have this beautiful multiply dot right in the middle. So I'm going to multiply first, and then I'm going to divide and simplify. So on the top, I'm going to add those exponents because when we multiply, we add the exponents. Same thing on the bottom. Okay? So on the top, I now have m to the 7th power. And on the bottom, I have n to the 4th power. Notice that 2 didn't change. The 2 is a coefficient. He's sitting right out front, nice and happy. Now the question is, can I subtract the 7 minus the 4? Well, you could say yes, but the problem is that they're different variables. So this is my answer. Okay, variables must be the same. You cannot do the multiplication and you cannot do the division if they're not the same. So all of your variables must be the same on every single one of these. Okay? Let's look at problem 20. Problem 20 also looks like a combination problem. This is entertaining because I have parentheses to a power. So I'm going to take this wonderful exponent on top and distribute it. And now I have to do the exact same thing on the bottom. Alright? So I have an x that's originally squared, a y that's originally cubed, right? And then on the bottom, my x was originally cubed, and my y originally has a first power. So I'm going to multiply each one of those exponents by the 2's that are on the outside. This gives me x to the 4th, y to the 6th on top, and x to the 6th, y squared on the bottom. Now we do our wonderful tug of war. If I look at just my x's, I have a 4 and I have a 6. Well, which one's going to win, the 4 or the 6? You got it, the 6. How much does he win by? 2. Now look at the y's. I have y to the 6th and y squared. Well, that gives me y to the 4th. Now I cannot subtract those two exponents because they're not with the same variable. They have to be the same variable. And this concludes our division with exponents.